For factoring by grouping, we have to have an even number of terms, 4 or more. This is different from what we did when we were just factoring using AC in the box method, because there we had to have 3 terms. So if you have 3 terms, you should proceed with the AC or box method. And if you have an even number of terms greater than 4 or more, then you should use factoring by grouping. You may want to pause the video to make sure that you have these steps written down. But the first step with factoring by grouping is always to split your polynomial into 2 equal groups. We do that by putting them in parentheses. And we want to always ensure that there is a plus sign between the groups. Once you have that established, we're going to factor out the greatest common factor from both groups. Now, this is something that you have been doing repetitively throughout regular factoring when you're finding out what can I take out of the top and what can I take out of the bottom, the left, the right. You're finding the GCF each time. It's also what you do before you start any of the factoring problems. Can I take something out of all of the pieces? That's called your GCF, or your greatest common factor. Then we need to check that what remains in each group is the same. So if I have in each group x plus 2 and then in the other group x plus 2 left over, then I know that I did this correctly. Now, if what's left over seems like it's the same but the signs are different, you may want to factor out a negative number. That'll get your signs to match. Once you've done all of that, you're going to rewrite it in factored form, and then you'll solve. Let's take a look at number 1. To solve this by factoring, I notice that this has 4 terms, so I'm going to use factoring by grouping. I'll split this into 2 separate groups, leaving a plus sign in the middle. Then I'm going to take out what I can from each set of parentheses. So I can take a 3 and an a squared out of the first set of parentheses. 3a squared, leaving me with 4a minus 3. Then we're going to look at the second set of parentheses and take what I can out. And the only thing that's common is I can take a 1 out. We have to take something, so 1 is the only thing that can come out, leaving me with 4a minus 3. So each of these sets of parentheses left over match. That means I've done something right and I can continue to write this in factored form. The matching set makes up one of my factors. And when I take those away, what's left over makes up my other factor, 3a squared plus 1. Now it's time for us to actually solve. So we will set 4a minus 3 equal to 0 and 3a squared plus 1 equal to 0. To solve, we'll add 3 to both sides, giving us 4a equals 3. Then divide by 4 on both sides so that a would equal 3/4. For the other one, we'll subtract 1 from both sides, giving us 3a squared equals -1. Then divide by 3 on both sides so that a squared equals -1/3. When I square root both sides, I'll need to put a plus or minus symbol in front of my square root, or in front of where I square rooted. So I'll have a equals plus or minus. The square root of a negative number leaves me I. Square root of 1 is 1, and the square root of 3, we have to leave as square root of 3. To rationalize this and get rid of that square root on the bottom, I'll need to multiply the top and the bottom by the square root of 3. So I'll have plus or minus 1 square root of 3, or just square root of 3. And square root of 3 times the square root of 3 is just 3. Now check to make sure we found all of our solutions. The degree was 3, so I needed 3 solutions. 1, 2, 3 with the plus and the minus. Let's look at number 2. So for number 2, I count that there are 4 terms. So I know that I can split these into 2 groups and use factoring by grouping. I made sure to leave a plus sign in the middle. What can I take out of the first group? I could take a p squared, leaving me with 2p plus 5. In the next grouping, I notice that I can take a 3 out of both of these, and that leaves me with 2p plus 5. What's in the parentheses matches, so I know I've done something right, and that will also make up my first factor, 2p plus 5. And what's left over outside of the parentheses is my other factor, p squared plus 3. We'll need to set each of those equal to 0. 2p plus 5 equals 0, and p squared plus 3 equals 0. Subtract 5 from both sides. 2p equals negative 5. Divide by 2 on both sides. P equals negative 5 halves. That's one solution. For my other solutions, we'll subtract 3 on both sides. P squared equals negative 3. Square root both sides, and p equals plus or minus. The square root of a negative leaves me with I, and the square root of 3 can't be reduced. So we'll have the square root of 3i, or you could rewrite this as I square roots of 3. Plus or minus I square roots of 3. The second is probably more preferable so that you can make sure that the I doesn't look like it's underneath the radical. Did I find all the solutions? The degree was 3, so I should have 3 solutions. 1, 2, 3. Number 3. I have 4 terms, so I'll separate them into 2 groups. Even if there were 6 terms, you would still separate them into 2 groups. What can I take out of the first group? The only thing that's common is x squared. That leaves 3x, and taking an x squared out of the second part leaves me with minus 4. Then we have 9x minus 12. What can I take out of both of those terms? I can take 3 out, and that leaves me with 3x minus 4. Again, I'm checking to make sure that what's in the parentheses is the same. That will make my first factor. And the other factor will be made up of what's outside the parentheses, what I took out. X squared plus 3. We'll set each of those equal to 0 and solve. We'll add 4 to both sides. So 3x equals 4. Divide by 3 on both sides, and x is equal to 4/3. That's one solution. For the other solutions, we'll need to subtract 3 from both sides. X squared equals -3. Square root both sides. And x equals plus or minus. The negative will come out as I, and square root of 3. We needed a total of 3 solutions. So 1, 2, 3. Now number 4 looks probably or maybe a little different on your page. So make sure that you change the signs to match what's there. Otherwise it won't make sense for you. So I see 4 terms. So factoring by grouping is a good fit. We'll split them into 2 groups. There's our first group. And our second group, if I were to just put parentheses here, I wouldn't have a plus in the middle, and I need that plus in the middle. So the negative needs to go inside and join the 2, and I'll replace the outside with plus. I didn't actually change the problem here because minus is the same thing as plus a minus. So it's important that we keep that plus in the middle. What can I take out of the first grouping? An x squared, leaving us with x minus 1. The second grouping, if I just took a 2 out, I would be left with x plus 1. And they don't match. Here's where I was giving you the hint earlier, that if the signs are what's wrong, oops, that would be left with negative x plus 1. If the signs are what's wrong, then try factoring out a negative instead. So if I factored out a -2, that would leave me with positive x and a -1, which is what I want. They match. So x minus 1 is my first factor, and x squared minus 2 is my second factor. We'll set them both equal to 0. And solve. Add 1. So x is equal to 1. Add 2 to both sides. X squared equals 2. Square root both sides. And x is equal to plus or minus the square root of 2. We needed a total of 3 solutions. 1, 2, 3 solutions.